All right, welcome everybody. Thank you for joining our latest webinar on a very key topic in today's industry is getting off the grid, specifically to critical facilities, which is one of the largest consumers of power. Jimmy is with me today. Let me just introduce ourselves. Jimmy Sneed is our managing principal and managing director of our critical facilities practice at WB. He's been, Jimmy, how long in this business now?
Oh, 30 plus years now.
Yeah, so he's seen quite a few changes in the critical facilities design and construction of, and he comes to this webinar with a lot of experience behind him. And my name is David Bonifacek. I'm the CEO of WB Engineering and one of the founders that started WB back in 1999 during the .com era. So as this is a AIA approved webinar, this is for everyone to know, I think there's a sign-in sheet and you'll get AIA credits for this attending. And as part of the AIA, we always list our learning objectives for this. And basically the bottom line is how we get off the grid specific to critical facilities. Jimmy, I hand it off to you.
All right. Thanks, Dave. And thanks everybody for taking your morning to listen to what I have to say a little bit about the mission critical world, in particular data centers and the power that they use and the impact on the grid and what we're going to do to address that in the future. Many of you have probably heard this stating data is the new oil, and there's a lot of truth and a lot of synergies in these businesses. Oil was a big boom in the early 20th century. And now we're going through a data center explosion. And I use explosion instead of boom only because I think the data center or the data revolution here is probably 5 or 6 times the size of the oil market right now, just in terms of capital. So yeah, it is the same, but it's a much larger industry. We've nearly over 150 years, we've really perfected how we do oil and how we deliver it. We're in the beginning of this data thing. It's 20 years, but it seems like we're still in the early phases of it. And the reason you can tell that we've done such a good job with the oil is when there's an accident, it's a big news. Like the Exxon Valdez, the Deepwater Horizon, these were huge news events. Well, there's 2 to 3 of these kind of events that affect us financially in data every day that we don't hear about. And that's because people are used to this data breaches, and that's something that will be addressed in the future. And security is a big issue, but for today, we're going to talk about power, which is also a big issue as these data centers grow. By 2030, we expect the planet to have about 8 billion people. And at the same time, there's going to be 25 billion plus smart devices. So basically 3 smart devices for every person in the world. So that's a huge number. So how does that impact the power usage around the world? Today, data centers consume 200 to 250 terawatt hours, so trillion watt hours of power. That's about 1% of the 22,000 terawatts we produce on the planet. By 2030, we think that's going to increase to 2,000 terawatts, about 8% of our energy production. And this graph kind of shows at the bottom, the dark blue is data centers. The lines above it are all the peripherals and the manufacture of devices, people's actual devices. As you can see, it's going to be about 20% of our electrical production is going to be based around data, producing it, viewing it. So that is a big number that needs to be addressed.
Jimmy, just if I could, if I failed to mention at the beginning, if there's any questions, please put it in the chat and we'll try and get it answered. And at the last 50 minutes into the hour, we're going to open up the mics for everybody to ask any questions. But we're looking for this to be back and forth between Jimmy and yourselves. So please don't hesitate to ask questions. Thanks.
And thanks, Dave. And one thing I forgot to add, I will be moving fairly quickly because it's a lot. But anything you see on these slides, we will be sharing it. And we'll actually share some handouts that may have more information. So please feel free to stop me. But if there's something, that you're worried you're missed on these slides, don't worry, you'll get them. And we can certainly take questions afterwards too if we run out of time after Q&A. But this next slide just really puts in perspective where data centers fit in. Actually, data centers around the world are consuming more energy than 5 countries, and we're not talking about third world countries. These are developed countries, and as you can see, it's even bumping up against the UK. So that's puts it in perspective to me about how much power we're actually using. So in and of itself, that 8% in 2030, will that be a problem? Maybe you can make the argument that our grids will handle that. But then when you got to look at things holistically, you'll hear me use that word a lot in this seminar, but we can't just look at the one issue. So another thing that's coming around the bend here is natural gas. People are phasing it out. They want to electrify everything. Well, of course, as we do that, that's going to tax the grid. A lot of the states on the West Coast have already adopted this. New York's adopted it. And so things that have traditionally been natural gas, like heating, will now be on our grid. So you add that on top of the data center issue, we're compounding the demand on the grid. The next thing that people are talking about or should be talking about is EV charging. WB is doing a lot of this as well. And right now, the EV charging consumes about 0.3% of the power in the world. By 2030, we think that's going to be about 4%. Again, looking at it holistically, data centers, EV charging, and going to electrification, this all is adding to the stressors on our grid.
Jimmy, we have about 7,000 EV charging stations right now. So just to give you a magnitude, one firm, and how much of an impact it is to the country.
Yeah, just our firm alone, we've done 7,000 plus of those charging and more to come. So, and everybody's doing it. And we're even seeing, it's interesting enough, we've seen even data center users that are starting to say, we're bringing in a lot of power. We're going to start looking at maybe fleet charging and stuff as well. So it's pretty interesting. Traditionally, when you look at our data center world, our primary source is utility grid. And then we go to the backup power as a diesel generator. Diesel generators have been the horse of our industry for years. They're very reliable. They can take the transient loads. We can drop block loads on them. They start quickly. But they are a necessary evil. So they do produce a lot of greenhouse gases. Luckily, we don't run them a lot. But when you do have to run them in big events, they do tend to have a pretty large output of greenhouse gases. So this next part is really quick. I'll go through this quick, but it was a power study we just did to look at how PUE and other things can affect how much you pay for your electric utility, and based on where you're located in the country and what kind of agreements you have. What we did is we just took a 6 megawatt data hall, for example, no particular client. We just said 6 megawatts. That 6 megawatts running 100% of the time. We're using a 1.5 PUE versus all the way down to a 108. As you can see, even at 8 cents a kilowatt hour, which we see some of our clients in, it's $6 million a year to run your facility. If you can reduce your PUE down to 1.25, you're going to save $1 million a year. So that's a lot. Really, that's kind of what we wanted to show here. And again, we'll share this with you guys. And if you have questions, we can talk about it later.
Jimmy, just for a second. Well, go back, please.
Go back.
Not everyone understands PUE. Can you just explain PUE?
Yeah, sorry. So PUE is power utilization effectiveness, basically. So what it does is it takes your critical power and your total power for your facility. You divide your total power by your critical power. So what we're looking at in this first example, 6 megawatts of critical power. We need 9 megawatts to run the facility, which means all of your ancillary equipment, your HVAC and all of that. So when you take 9 divided by 6, you get 1.5. And the last example there, in example 4, we're only using an extra megawatt, which is a 1.08, which is very aggressive. We've seen a couple of users get to that point, but typically you have to have some sort of free cooling or something that we can get most of the HVAC out of the building to do that.
And a 6 megawatt generator is, how many square feet is that roughly?
Well, it depends. Everybody's different, critically different, but it's 30,000 square feet, maybe something in that range, maybe 40.
So it's a 30,000 square foot data center. The electric utility costs can vary between 11.3 million to 15.7 million.
Yeah. So to clarify that, the data hall is probably that size. Then you've got the footprint of the building outside of that, you've got sites, assuming all the stuff on the site. So we're seeing more and more people put their electrical distribution and everything outside the footprint to keep so they can increase their white space, of course. This next example really was just to look at generators and what it's costing us to run generators from 2 years ago to today. Again, we looked at 2.75 megawatts, 4 of them to run this 6 megawatts, up to 9. So in June of 2020, diesel fuel was $2.40 a gallon. Today it's $5.70. So basically we've more than doubled what it costs to run a generator. So this was just an example of how that PUE can also affect your generator cost. The more efficient you can be with your power, the smaller your generators can be. So this is basically just looking at fuel consumption. And again, just for reference. So once you get to that, the next thing that people think about in their data center is site selection. And so with power being what it is, what we think about, one of the first things everybody thinks about is environmental considerations. We don't want to be where there's a lot of natural disasters. And the weird part is, with the way that the climate has been shifting, it's kind of hard to keep up with that. Now people that weren't in these situations before suddenly have been thrown into these situations. Like there was tornadoes in Chicago a couple weeks ago. That's kind of unheard of before. And the fires in California, it's not necessarily a direct fire threat, it's the smoke, right? And to not only the health of your people, but filters in your facility, all of that has to be considered. So people try to stay away. Is there land available? But the big thing to me is there power? Is the power reliable? Do you have the ability to get redundant power? And also that for fiber and fiber availability and redundancy. A lot of times we'll find the site, it'll be cost effective. There's tons of power, but there's no fiber. And that's an expensive venture to get fiber to the site. That's why you tend to see people cluster. So this next slide, we kind of show that. This is installed megawatts of power. Northern Virginia is not only the largest location in the country, it's the largest in the world for concentration of data centers, but we're starting to see areas like Phoenix and Dallas, which in the past people would stay away from because of the heating. We were naturally driven to go to colder climates to take advantage of free cooling, but now we're starting to see, with the cost of power, and tax incentives, and things are just technology's getting better. People are finding that it's more advantage. It's a bigger advantage to be in these areas. And again, as one goes, tend to follow. We see corporations tend to cluster. That way they share the costs of things that have to be brought in, or somebody's already laid the path before you get there. So we find that's pretty interesting as well. So with all of that, we've talked about power, and now really what we were wanting to talk about today was, what do we do, right? How do we address this, what's been happening? So when you start thinking about sustainability, one of the first things you got to think about, what's the metrics you're trying to do? What are you trying to reach as your company? For example, Microsoft has a very aggressive, by 2030, they're going to be carbon negative, not neutral, but negative. They're going to start extracting carbon from the environment. How they're going to do that, we'll see, but that's their goal. And by 2050, they say they're going to have extracted all the carbon they've ever put into the environment since 1975. That's pretty aggressive.
And Jimmy, you got this information from Microsoft.
Yeah, this is press releases from Microsoft. That this is everybody knows what their metrics are. Apple's the same way. Apple's another one. And the interesting thing about Apple is they've made the statement that says anybody that wants to be a supplier for them has to agree to be 100% carbon neutral in 10 years. So it's going to affect your supply chain. It's, again, holistic, not just looking at yourself. And where I find this interesting is I don't know how this is going to affect our colo clients. Like our colo clients today do build things to meet the requirements of their tenants. But I'm wondering when Microsoft and some of these larger Googles and Amazon starts pushing down to some of the colos and says, we've got this carbon negative goal. We're going to expect you to do the same thing, or at least be carbon neutral. So I think we're going to see a push into that as things progress. The next thing people tend to ask us is, we don't have a lot of CapEx day one. What can we do to start reducing our footprint, today? What's something we can do in incremental steps? And we'll talk about that in a second. And then finally, what's the long-term steps to carbon neutrality? The sustainability metrics that we all look at is energy, greenhouse gas, wastewater, and then land. The ones we're going to concentrate on today is energy and greenhouse gas. Water is a very, very important one that we'll probably do some sort of seminar in the future. But it's, again, holistic. Energy affects greenhouse gas. Energy affects water usage. It all affects them. They're all intertwined. For example, for years, when we would do a water-cooled system, to save water, we said, let's go to air cooled. So you go to air cooled, makes sense. It reduces your water substantially, but it drives your power up. And there's been a few studies, I think Schneider's done them, and some other studies that shows that the water you saved, actually the power plants were using 4 times that amount to create the extra power that you were using now. So again, this is as we get into this new sustainability world, these are the things that everybody's going to have to address. How are the decisions I'm making affecting people down the street? And they're going to be expected. Some of these larger corporations are going to hold everybody accountable to make sure we're thinking about that. Energy, again, we're talking about PUE. This is just an example of what's happened since they started tracking PUE in 2007. That's basically when this term came to be. Well, there was a pretty substantial drop between 2007 and 2014, but since then we've kind of leveled off. That's because technology is what it is. And this was from Uptown Institute. They surveyed the largest data centers in the country. We don't design things to 1.57. I think most of the clients we're seeing now is in the 1.3 to 1.4 range, but these were the larger hyperscale guys. So you can see it's it's leveled off. So now we've got to figure out what's the next way to start reducing energy. And
the good news, Jimmy, is the industry as a whole has really, back from 2.5. Oh, yes. Now we're listening, and as an industry as a whole is trying to address this. Correct. Whether it's the manufacturers, the engineers, and
if you go to any of the conferences and hear the manufacturers, they're out in front of this. And again, with the amount of power we're talking about using, our industry, the data center industry in particular, is going to have a lot of influence on how we do things, but also how the utilities are going to approach things, because 20% of your capacity is going to be going to this group of users. So it's pretty important. So we look at how much total energy, how much renewable energy are you using? There's a renewable energy factor, basically from 0 to 1.0. It's pretty simple. If you're using no renewable energy at your place, you're a 0. If you're using 100%, you're a 1.0. So anywhere in the range there is what we're starting to see more people look at that. And another one is energy reuse. This particular photo, it's hard to see, but it was a data center that's being designed in Wyoming. It's a hyperscale data center. It was really interesting. They're going to take water out of an aquifer and use that for their heat rejection in their data center. They have no outdoor equipment. It's all indoor. And as they reject the heat, they're going to pump the heat down the street. And in Wyoming, one of the problems they have is supply chain for their vegetables. They're trucking them in for California. So they thought, how can we improve that situation? So they're going to build a hyperscale indoor farm that they're going to pump their water to, and then offload the heat at this hyperscale indoor farm, and then bring the temperature of the water back down and then reintroduce it into the aquifer. So there's a 0% water usage. There's a lot of things that I'm sure they're still figuring out, but this is actually under construction. It's going to be 120 megawatts in the future. They're building 30 megawatts today in the first 30 megawatts of the indoor farming facility. So that's an example of a company that's thinking, what can we do not only to help ourselves, but what can we do to help our neighbors? So that was really interesting. Greenhouse gases, the next thing that's a big deal that we're trying to deal with. It's broken into 3 scopes, basically. Scope 1 is your direct emissions, anything that you're creating at your site. So your diesel generators, if you've got your hydrofluorocarbons that are coming off of your HVAC systems, all of that's considered your Scope 1 emissions. Scope 2 emissions are anything that's being produced at power plants or anybody that's delivering power to you. we've obviously, as the coal fire power plants are online, the natural gas power plants, all of those are producing CO2 and all of the greenhouse gases. So that's your scope 2 emissions that has to be weighed along with yours. And then scope 3 is your supply chain. So basically any kind of emissions that you're during your business travel, if you take a jet somewhere, you're adding to the carbon footprint. So as we're starting to look at things again holistically, we have to start thinking about, if I do make a change and here at my place, how does that affect my other emissions? And one example that's really interesting is batteries take us off of the grid. They have zero emissions, but the process to build the batteries is super dirty. So you'll start hearing the terms embedded carbon. Most of you have probably heard this already, but they're starting to rate devices about a battery, about how much carbon it took to make it, and they consider that embedded carbon, and batteries have a really high embedded carbon. So they're trying to improve that. But for now, that's one of the things when you look at, I'm trying to offset greenhouse gases. Are you really? Maybe not. So it's just things we have to always consider going forward.
And Jimmy, PFCs and HVACs, what are those for everyone?
So just different types of particulates. They're fluorocarbons. Hydrofluorocarbons are like, the off gases and stuff. It's just different fluorocarbons. Anything That's considered a greenhouse gas. We've been talking about those on layer and stuff for years. This is all stuff that affects it. So again, after we talked about metrics, one of the things people ask is, okay, I've got all this diesel generators installed. I have no desire to switch my diesel generators out today, but maybe in the future. So what can I do to start thinking about reducing my carbon footprint? One of the interesting things that we've seen, and it's becoming a bigger player, is hydrotreated vegetable oil. Basically, it's the second generation of biofuel. Most of you have probably heard of biodiesel, and people tend to confuse these two. They're not the same. Hydrogenated vegetable oil has a much longer shelf life than the first generation biofuel, and it will reduce your emissions by 90%. Now, it is a drop in the bucket, right? Because your diesel gens aren't running all the time. And most of the data center users that are on this call, you don't use a lot of fuel unless there's a big event. So it is a drop in the bucket, but it's a start. And anything you can reduce is very positive. One of the greatest things about this HVO is that you can blend it with diesel fuel from 1% to 100%, and your diesel generators will run. And so, for example, if you've switched over to HVO and there's a major event and you can't get it, then you can go right back to number 2, but you could get diesel for some reason. You can go right back to number 2 diesel without any changes to your system. Won't affect the generator. It does not affect the warranty of the generator. It won't affect the emissions certifications on your generator. And the reason it doesn't affect your emissions is it reduces greenhouse gases, but it does not reduce particulates and the noxious fumes and things that are considered as part of your emissions. So it won't affect your emission certification, but it only will reduce your greenhouse gases.
Will your data center smell like a McDonald's cooking French fries?
Yeah, like French fries. Some of the disadvantages, it's more expensive than diesel, and it does reduce your generator output by about 2%, but most of our data center clients, you're running at 80% capacity, maybe 85. So 1 or 2%, you're probably not going to see that. And that's an acceptable risk for people to reduce their footprint, but it needs to be considered. The manufacturers have said they could make changes to their units to make them run at 100%, but I don't think they're going to invest that kind of money for something to pick up that 1 or 2% unless it really started pushing back. But to me, I think it's a good first step, and that people should consider if you're really thinking about what can I do. One of the other problems with this is it's hard to get. It's not produced readily across the country. California is big on it, so we're seeing California use it a lot. A lot of this goes to trucking too, so they get a big shot of it. So, but if you do have a supply of this, or you're in a market where you can use it, it is definitely worth exploring. Another one, people that have natural gas generators, you can think about using renewable natural gas, which is basically methane, right? We're capturing methane from farms, from landfills, and converting that into basically a usable natural gas. This, we're starting to see what happens is California, again, leading the way on this. They are kind of blending this in with their natural gas. We'll see them infuse this into their system. It is a renewable source. It's highly reliable. The disadvantage is, again, unless you're sitting next to a farm or sitting next to a landfill, how can you get it? It has to be trucked into you, or like I said, sometimes you're seeing it infused, and you can do offsets where maybe you're buying true natural gas, but then somewhere along the system, somebody's injecting this renewable natural gas into the system, and you're buying the credits for that. That's another thing I'm seeing happening. There's a Microsoft, I know we keep talking about them, but they're kind of leading the way. They're building the largest microgrid in California. It's going to be 100 megawatts. It's 200. It's like a really ridiculous number of generators. And they're saying 100% renewable natural gas is what they're going to use. But really, in reality, they're going to be using natural gas. But the company that's building the microgrid for those guys are going to be injecting the same amount of renewable natural gas into California's gas grid. So that's how Microsoft is able to say, we're going to be 100% natural gas, because technically they are, even though their generators sitting on site are most likely going to be running on true natural gas.
Jimmy, just define microgrid for everybody who doesn't know.
Yeah, so microgrid, we'll talk about it a little bit later, but microgrid basically it's a small copy of a grid. So you're putting your supply and your distribution all under in a smaller package and setting it somewhere where you can control it. And I'll talk about that a little bit more in detail when we get to that slide. But yes. So those are a couple of things that are initial. There's other things, we could talk for days on this, but I just wanted to say a couple of things that I see clients have asked and that I see things talked about in the industry. And then after we get past those initial steps and we start thinking about more long-term, how do we get to our goals of becoming carbon neutral or carbon negative? What do we do? So most everybody here knows what solar power. Solar power is. It's a very clean energy. Clearly, it has a lot of advantages. You can reduce your carbon footprint. In 2020, the U.S. has about 97.7 gigawatts. I think it is of. And I got this from, I can't remember if it was from the IEA or who this was from, but 97.7 gigawatts installed, and we're installing it. It's increasing every day. Basically saved about 2 billion trees if you looked at it on the, your carbon footprint reduction. If you have this, it can, if you're having solar installed at your facility, say for maybe for your office areas, not necessarily for your data center, or you're using it just to save some areas, you can certainly reduce your utility bills. There's potential state and federal tax incentives. A lot of those are really drawing down on solar power. They're getting small. I think by 2024, it's really just going to be commercial applications that can get it. It's going to, because it's become such a commonplace to do these things. It will help reduce strains on the grids, because anything we can do to shave the power off of the grid, it's going to help. And you can actually sell your power back to the grid if you build a large enough farm or solar farm to produce more than you need. You can certainly sell this back to the utilities in most cases. You just have to have an agreement with them. Disadvantages to solar is it takes a lot of space. It's a huge footprint, to put a lot of cells, as you can see in some of these pictures. It's a large capital expense day one. It's not cheap. They're difficult to move. Once they're in place, it's not something that easily moved. So if you're building a farm with the thought that I'm going to eventually move it and put something else here in the future, you don't really do that. So you have to really plan for these farms in advance. It's not like you can repurpose that and keep the farm or move the farm. If you're going to use it for really driving your facility after hours, like at night, you're going to have some sort of battery storage. So again, that gets expensive and has a large footprint. And it is an intermittent source. Weather impacts solar, as does night. At night, you're not going to see it. And it's interesting being in Texas. I'm in Austin. We have talking about power demands and looking at solar every morning with the weather forecast, because we've been over 100 degrees for like a month straight here in Texas. And every day they give the weather forecast. They also give an energy forecast, which is interesting, that shows ERCOT has about 81 gigawatts, or excuse me, gigawatts of power supply. We're using about 78 of it in Texas. So it's a problem, and as we start adding more of this data center type environments, we start adding EV charging, that's going to drive that up. So we're going to have to build capacity. So whether we're doing it on our sites or the utilities are building these large solar farms, and Texas is big on solar and wind, which is the next topic we'll talk about. Wind power, which is also very clean. It's a renewable source. Wind is renewable. It's relatively low operating cost once you build it. The fuel source is wind, so you're not no fuel to run these things. They're pretty low maintenance. But not free, but they're pretty low maintenance. Prices are decreasing since 1980. Windmills have dropped by about 80%. There's a rapid growth in the technology. So I recently was reading articles, especially about the offshore windmills that we're seeing. I think GE's building one that's like 30 megawatts or 34 megawatts, something like that. To me is crazy to think of a windmill that big now. It's huge. And the only place you can do that is on an offshore kind of environment. And that kind of leads to some of the negatives, which is they tend to be remote. So you've got a distribution problem. How do you get it from wherever they are? Because wind doesn't occur, or the kind of wind you need to drive these wind turbines doesn't happen everywhere. So there's, unlike solar where we can build it anywhere, wind power has to be where the wind studies show us it's going to be. That's why you see a lot of these through the plains into the panhandles in Texas and things, because the flat open plains with lots of wind. California has some really great wind across the Altamonte Pass there. A lot of wind, very constant wind. You want it somewhere where you can count on it. Some of the negatives still, it's a really high initial cost. These aren't cheap to build. It's an intermittent source. Wind stops. It still can be a threat to some migratory species. So some birds are still susceptible to crashing into these and dying into these windmills. It's a lot better now with these larger turbines than the smaller ones that we used to have with the high-speed propellers. Those were the really rough ones. Now it's a little better, but it's still a concern. And noise and visual pollution. So they're not pretty. You see this picture on the bottom right. It kind of looks strange. People don't want them in their neighborhoods necessarily, but it's a good application for farms. We see that a lot of times where they'll put them out on farmland because it doesn't interfere, but that's a consideration. Next thing that's emerging, and I think this technology has probably it's going to have some staying power. I think maybe not as a standalone system. Battery energy storage system is what we call it. It's a BESS. Most everybody in our industry has experience with batteries to some extent, whether it's UPSs or if you do have some solar on your campus, you may have some battery storage there. So we're all familiar with it. It's an absolutely proven technology in the data center industry. I think it's going to have play, especially with the future of hydrogen. We'll talk about that in a second with some of the hydrogen systems. And really where I see, I think it's going to have some staying power, I believe. It really is critical if you're thinking about gas generators, because gas generators typically don't accept transients and dropping loads on them as well as a diesel generator, or they don't start as fast as diesel generators. So to have these batteries, to help assist those generators as we go to this more green environment, I think is going to make a lot of sense. I think right now we're seeing them used to stabilize grids, where, to clean your power, to drop transients. We're seeing that it's becoming more and more a given. Another thing that I think is a positive, I heard this at one of the conference, is a time shift, which is basically peak shaving. So you can charge your batteries when power is cheap. When power spikes, you can start discharging, to peak shave those events. The only problem with that is obviously batteries, the more you hit them, the chance of replacing them, you're going to have to replace them. The benefits, they're extremely fast, milliseconds to respond to an outage, extremely high power quality. They have no emissions and they're quiet. Some of the negatives, they're still expensive. The footprint becomes a problem because based on whatever your duration of your discharge you're looking for, it just gets enormous. And you can see, I think this picture at the top is from one of Tesla's facilities where I think those are like 3 megawatt, maybe 3 megawatt each one of those little compartments. But it does become a large footprint, and that's for like an hour or two. So I think anything 2 hours to 4 hours, is pretty reasonable. But once it goes over 4 hours, it's going to become unwieldy. So you're not going to see batteries. I don't think we're going to see batteries as a standalone backup on a site unless you've got a really strong rollover plan to like roll from one facility to another. And then it becomes a software driven exercise, right? Like as your batteries start to drain down, you have to say, I'm going to roll all this data to another facility that has primary power available because I'm going to lose my batteries. That's why I don't think you're ever going to see this as like a complete standalone, but it could. Yeah, it could operate that way. But, that's the bigger negatives I see.
And Jimmy, they're probably very heavy. That's why they're on grade versus.
Very heavy. Yeah. And it's interesting. Dave and I had a discussion about this. We'll talk about nuclear soon, but there's a big push, a big power struggle going on between Bill Gates and Elon Musk about what's the future. Is it batteries? Is it nuclear? So, we're going to continue to see these kind of discussions. And one of the things as we try to imagine what this is going to look like, nobody knows for sure. It's still a gray area about how we're going to get to where we need to get. But the key is to always be thinking, right? We need to be thinking about what can I do? What combinations of these things can I do to help not only ourselves, which is definitely a goal, but the environment and the community at large. The next thing we'll look at, and this is where I have a lot of excitement, is with hydrogen. We've had problems with fuel cells in the past, but there's a lot of money being thrown at hydrogen now. Hydrogen is the most abundant element on our planet. I think there's a couple of different types of fuel cells. Actually, first, before we talk about that, talk about reciprocating engines, because CAT actually has generators that can run at like 25% hydrogen. So we are seeing that there could be a potential for hydrogen to be injected into some natural gas systems to be used in conjunction with for these generators. And CAT's actually in developing one that's supposed to be out shortly that's going to run on 100% hydrogen if necessary. So hydrogen is it's a super clean if to burn it. And the problem in the past has been, how do we extract it? Some of you've probably heard of gray, blue, and green hydrogen. Basically, those are the different levels of how it was produced. Gray is pretty dirty. However, how they produced it, it's a lot of carbon emissions. The newest hydrogen, it's called green hydrogen, is basically 100% carbon neutral. So it's very exciting about what they're going to do with fuel cells in the future. There's a couple of different types of fuel cells. You'll hear the PEM fuel cell. You'll hear solid oxide fuel cells. The PEMs are really, what they're good for is like a really short duration, maybe to take the hit on the grid, maybe like a generator, but they're not made to run long term. The solid oxide types are they start slow as their negative, but once they start, they want to run for a long time. So if I ever see something becoming like a shift to, say, from the utility to something as primary power, it may be these solid oxide hydrogen fuel cells in the future. Now, what we would do here, again, going back to batteries, since these long-term cells are slow to start, but like to run for a long time, maybe we have to have batteries in front of them, just like we do in generators, to ride us through till that fuel cell can get up and ready to accept the load. But then once it's on the load, it goes. So it's pretty exciting about what we can do. Now, there's a lot of negatives to hydrogen too. Number one is the supply chain. How do we get it? There's no pipeline to your facility for hydrogen. Basically, it has to be trucked into your site. I think eventually they're going to address this. Some people are injecting it into the system, but I think eventually there's either going to have to repurpose some of our old natural gas lines for hydrogen as these plants come online, or build a new hydrogen system, which could take years. I keep hearing we're 5 years out. How come we're 5 years out when this technology is supposedly a proven technology? Well, it is the supply chain, and how do we get the actual fuel to the site? And then there's the small issue of we need to make sure it doesn't explode. Right? So that's a huge concern when you're storing hydrogen on site. It is very flammable, and it's definitely an explosive chemical, or excuse me, explosive element. But otherwise, once they figure that out, it's super green, and I think it's just, I see that as one of our go-tos in the future, and a lot of money's being invested in it. And one of the reasons being, with hydrogen being so abundant, even though we're trying to get off the grid and get away from gas, we're all in the middle of this gas crisis, and we want to get away from being dependent on other countries, and we want to be energy independent. Let's go batteries. But where does 80% of our raw materials come from for batteries? It comes from China. So we're switching one dependency for another until we figure out how to get our arms around that. What are we going to do? The U.S. recently signed some agreements with Australia, which is great. But again, we're going to be at the mercy of some of these countries on raw materials for anything that we produce. The last thing is a very controversial one, nuclear. Obviously, there's people that have very, very strong opinions about this. Bill Gates is a big proponent of this technology, and I find myself leaning toward being the same. I think there's a large future in it. I understand people that have their concerns because they're legitimate. We're starting to see more research into SMR, small modular reactors. This picture on the bottom right is actually from Rolls-Royce, who's working with the English government, with the UK government right now, to develop a series of these modular reactors. They're having a lot of issues with it. Surprisingly, it's a new technology, but the UK is investing heavily in trying to figure this out. And the exciting part about that is, as we start talking about microgrids, where will the play for these be? I think there's a potential for these in the future for microgrids. This particular one that they're developing is about 470 megawatts. So, it's not like for one data center or for one user, but maybe if you're building a campus and you're going to have 400, I definitely could see 400 megawatts on a campus, or you're sharing it with a neighborhood. People like Facebook, who already export some of their power to hospitals and things like that over in Europe, especially. I could see in the future that something like this could play. The benefits, it's completely carbon neutral. While fossil fuels have a large carbon footprint, nuclear facilities have none, no carbon emissions whatsoever. It's a relatively small footprint. You can get about 1,000 megawatts in a square mile of facility, whereas it's about 360 times that area for wind and 75 times that area for solar. So it's about 431 wind turbines, if you're curious, and over 3 million solar panels to do that, the same 1,000 megawatts. So very
Jimmy,
high.
the waste from the nuclear rods. What have they figured that out?
They have not. The U.S. government definitely invests. All the governments around the world are definitely invest a lot of money in understanding how we are going to deal with this in the future. But it is something we have to overcome. That is one of the big negatives. One of the disadvantages is the nuclear waste. It's expensive to build these things. They're not cheap. And uranium, technically, which is what we use in these plants, is not a renewable resource. It's a limited resource. I know we're looking at other ways. Eventually, is there another way to fuel these facilities? That's all in research. And malfunctions can be catastrophic. We all know. We all lived through Fukushima, and most of us remember Chernobyl, and some of us older ones remember 3 Mile Island and how scary that was. But so that is the thing, the fear that drives everybody is, I don't want that in my neighborhood. And that will always be an issue until we get our arms around it better. I do think there's a large potential for it. I think when you start looking at just the sheer amount of power we're going to need, we're not going to be able to do it with wind and solar alone. It's hydrogen's a play. But when you look at it on large scale, how are utilities going to deal with it? To me, nuclear energy is it's going to have to happen. That data center I was talking about a little bit earlier in Wyoming, that's where Bill Gates' company is going to have one coming online. I think they said around 2030 or sometime around there. And it's one of the ones that's got the molten salt coolant instead of water. So it's the newer technology. So it'll be interesting to see how this goes. But I do see this. It is very clean. I do see it as being a player in the future.
Jimmy, so the mics are open for everybody if they want to chime in. But there is a question from someone that I noticed data center. I'm going to quote. I noticed data center folks saying carbon neutral instead of net zero. Is there a reason for this shift? Question mark. It seems like we switched from net zero back to carbon neutral. Yeah. Just curiosity.
Yeah, I think to me, it's the same term, right? Net zero energy. People are more concerned about the carbon footprint, but to me, it's the same thing. If you're net zero, you're carbon neutral, right? If you're using all sustainability, you're going to be carbon neutral. It's just they started using these terms together. I think today you're right. We used to hear net zero all the time. Now I'm going to be carbon neutral. That's just the new buzzwords.
But is carbon neutral interject, as you say, the complete chain of events in the beginning, whereas net zero is more on
in the past, right? We said in the past we've said we're going to build a hotel or something that's net zero. And which means we're going to use thermal power or thermal heating. We're going to get heat out of the earth. We're going to be using zero here. But really, how does that affect the environment? We never used to look at that. And now as the environment becomes more and more of a concern, we're starting to look at that. So it's not just being net zero myself. I need to be carbon neutral across my industry, across my operation. For sure. That's what we're starting to see.
Hope that answers.
Yeah, I hope so. And then the last slide that I wanted to touch on before we open it up for questions is microgrids, which I think is obviously a big future for all of us. So basically, it takes all of the things we've talked about and we build it's essentially a smaller version of the grid. It's a localized group of electrical sources, right, that we're going to connect. But we're actually going to be connected to the traditional grid as well. So most of the time, the way these are set up to operate, we're going to run on the grid when power is cheap or whenever our operations wants us to run on that. But if we wanted to drop off the grid and be 100% independent from the grid, we can. And if we want to create more power than we use and sell it back to the utility, we can. So these are a big financial investment up front, but they can pay off in the long run. You're saving the cost of energy. You're actually selling energy back to the utilities. Some of the utilities are still having resistance with that. You still got to work on your renewable, how you're going to do that. Actually, the bigger areas that are like in California or any of the large metropolitan areas, this is not a problem. But then sometimes when we go into these remote areas, like if we're going to build in the middle of Texas or in the middle of Nebraska somewhere, or whatever we're going to build, where it's a really small community, they have no idea what we're talking about. So, and even the utilities are like, I don't know what you're talking about. I don't even have a plan to deal with something like this. So that's where this becomes challenging. It's how you deal with this in certain areas that have no idea how, from the utility side, to interact with your microgrid. But if they're planned correctly, and you can get that buy-off from the utility, it is a huge advantage, right? Because you now can control your whole environment. You can control the power. You can control when you use the power, however you want to do it. So it's very powerful. It's not cheap. It's a big financial burden up front, but I think the paybacks are substantial. It's very reliable. You can, like I said, completely disconnect from the grid. If it's planned right, you can run forever off the grid, as long as you can get whatever you need to get. If it's natural gas for your generators, or whatever, but if most of it's renewable, in theory, you could run off the grid forever. And an example of a microgrids that I thought was pretty cool was we've all seen Top Gun. So the Miramar base in San Diego has a microgrid that started planning in 2011, and it opened basically came online, I think, in 2019. So during the summer of 2020, San Diego Gas and Electric came to the Navy and said, hey, we're going to have this heat wave through Southern California. It's going to start rolling blackouts. So they said, can you reduce your energy that you're taking from us, which they did. So the Navy said, of course, because we have a goal to be off the grid anyway. So yeah, this is a good test for us. So they went off the grid at certain times. It was 3 different times during the summer of 2020 and actually kept California or San Diego Gas and Power from rolling blackouts to 3,000 homes so in their community. So that was a huge advantage. The community loved them for it. They're like, hey, thanks for saving us from being without cooling and during this heat wave. So not only is it helping you, it's helping your neighbors. It's reducing the carbon footprint. This is why it's attractive to so many people. So with that, that's kind of where I end. And looks we got about 5 or 10 minutes for questions if there's any questions.
And if anybody would please, we encourage everybody to take a scan and do a survey of the webinar. That'd be greatly appreciated. Just scan the QR code and answer any questions that pop up.
And I hope again, this was not an all-inclusive seminar. We could talk for days on any one of the topics that I went through today. But if, hopefully if you have more questions, ask questions today, but certainly reach out to me, reach out to us with any questions you have, or if you want us to talk more about any certain technologies or our thoughts on anything.
Okay. I think we're good, Jimmy.
Okay.
All right. Thanks, everybody.
Thank you, everybody.